Throttle on, maximum speed. Assalamu alaikum. I hope you're doing great. We'll continue with building a drone part 2. We will be testing the drone motors. What you will learn in this project: important components found inside the BLDC motor, to differentiate between outrunners versus inrunners BLDC motors, how to determine the direction of the propeller rotation, how to wire the BLDC motor with an ESC controller, and finally measure the thrust and speed produced by the BLDC motor. List of material as before: brushless motor, jumper wires, 11.1 volt battery, an ESC controller or electronic speed controller, and a servo tester, digital balance, a 3D printed arm for testing. This is the motor we're going to be using in our drone. Zing GI 2208, 18 kV rating. It has 12 magnets. It's an outer runner. It has 14 permanent magnets and 12 coils. The same components inside this motor is what we have in the slide. The inside of our motor, we're going to have a rotor which carry 14 permanent magnets, and the stator that will have 12 coils or windings. So this is the inside of the motor. And you will have sensors called magnetic pole sensors that basically let the ESC know when to switch from one magnet to another magnet. And finally a shaft that actually where we put the propeller. So the in-runners versus out-runners, the one that we had before, it was an in-runner. The rotating part is inside, so the rotor is inside and the stator is outside. As to outrunners, like the one that we are using in our drone, the rotating part or the rotor is outside, so the stator with the winding is inside, so the rotating part is outside. That's the difference between outrunner and in-runner. So let's focus on the outrunner BLDC motor, like the one we're going to be using. Its rotor is containing this rotor is that part that is rotating. It's containing permanent magnet. These are permanent magnets that rotate around the stator. The motor controller or the ESC is connected to the power source in one side and to the motor on the other side. Propellers are devices that transform rotary motion into linear thrust. The drone propeller provides lift for the drone by spinning and creating an airflow, which results in a pressure difference between top and bottom. And because of this pressure, the lift is happening. There are many propeller sizes: 3 inches to 7 inches, 8 inches to 10 inches, 11 inches and above. How to determine the propeller rotation direction? So you have to be very careful when selecting the propellers. As you know, we're going to need a pair clockwise that goes with the motor, and a second pair rotation counterclockwise. How do you know which propeller is clockwise and which one is counterclockwise? Well, by looking at the one that we have here, by inspecting the propeller, you will see basically one side that is thicker. That side basically, it will be this thicker side, it will be a leading edge of direction of the rotation. So that's how we can determine that this is basically clockwise. As to counterclockwise, the thicker side, or the thicker side of the propeller, that will give us the direction of the counterclockwise propeller, and that's how we determine that this is counterclockwise propeller. Just looking at the side of the propeller, you can tell which one is clockwise and which one is counterclockwise. As I mentioned, clockwise, the edge, the thicker sides go in direction with the clockwise movements, and counterclockwise propeller, their side, the thicker side, go with the counterclockwise direction. How to wire BLDC motor with an ESC controller? So basically, the brushless ESC controller creates a three-phase AC power output from a DC power to run the motor by sending a sequence of AC signals generated from the ESC circuitry. So let's say we have our ESC here, controller. We have a power source, which is our 11.1 volt LiPo battery. From this, we have a DC current being converted to an AC current, and that's why we have three wires here, okay? And using at any one time, only two wires are being activated, okay? And this is how we run a DC motor. We're going to be using a servo tester in this project to control basically the speed and which phases we're using to run the motor.
This is the test setup for the 2208 brushless motor. What I have here, I have a 3D printed arm, servo tester, 11.1 volts with 5000 milliamp hour, and a digital scale. Let's turn it on and check the thrust. What is this motor can do here? I'm gonna start turning the throttle on, maximum speed. I do 600 grams. Whoa, very strong, very strong, very strong. I'm gonna reduce the throttle now. Very strong. Good test.